Hi everyone, for the tutorial or just for people who need to study, I'm going to talk about all of the parts of this quiz. So first question, when you're doing a lab, the step after the observation is the analysis. It's making that graph and talking about it. And so analyzing your results. In an experiment, a responding variable, that's usually the variable that responds to the whole experiment. So, it is the one that you have observed or measured. It's the results. What is a manipulated variable in the experiment beside? So here they're saying that they have 3 plants and they're applying 3 different brands of fertilizers to each plant, and they show the percentage of these 3 substances in every brand. And so they're looking at what happens after 2 months of growth period. And these are the results. So every fertilizer brand has produced a plant that shows different characteristics. So in this situation, manipulated variable is what's predetermined before. It's not the results, but it's what's already preset in your observation table. And so it's the brand of fertilizer. Now it's asking what conclusion can you make out of all of these results. And so which one is accurate? Well, here it says nitrogen promotes leaf growth. And so what you're going to have to do is look at what brand has the most nitrogen. So it seems like this brand Y here contains the most. And then you go look at what Y is producing the most of, and it's producing the most leaves. So yes, this one is right. It does promote leaf growth. And then potassium promoting flower growth. So you go look at potassium. It has 17% here. So brand W has the most potassium, and brand W is creating the most flowers, bigger number. And so yes, potassium does produce flower growth. So your answer is A. You don't even need to look at the other ones. Okay. Next question, convert millimeters into meters. So I'm just going to make a little scale here. Okay, so when you go up, you have to divide by 1,000, and when you go down, you have to multiply by 1,000. You guys are going to have this for your quiz. And so if I were to convert millimeters into meters, I have to go up once, so I'm going to divide by 1,000, and that means moving my decimal point 3 positions to make it smaller, because I have 3 zeros here. And so this gives me 0.3218 meters. Next up is grams into micrograms. So if I start at grams and I'm going down to micro, that's 2 steps. And so it's times 1,000 times 1,000, which means times 1,000,000. Oops, that's one too many. And so 6 positions, 1, 2, 3, 4, 5, 6. I count the amount of spaces. There are 3, which gives me equal to 3,000 micrograms. Here I am connected to the 500, so I'm using this scale, and so my needle is between 200 and 300. And if I'm not sure what is the value of every interval, I go to the first number between 0 and 10. I divide by 10, it gives me 10. Okay, so if you don't remember, you go the first value from 0 to this number. If you divide it by the 10 intervals that there are, it gives you the value of this one, which is 10. So here I'm 1 shy of 300, so I would say 300 minus 10 gives me 290 milliamps. Okay, because you can see here it's milliamps. This one here, it's connected to 15, so same thing. If I'm not sure of what one interval is worth, I go from 1 to 5, and so I go 5 divided by 10, it gives me 0.5. So I know that this is worth 0.5. And so here I'm at 5, and I know I'm one interval past that, so this is 5 plus 0.5, giving me 5.5 volts because the V, okay? And so this is my answer. Over here, you have 12 milligrams of mercury in 900 gram fish. Calculate ppm, which are parts per million. So I want to know how many parts per million parts. Okay, and I have to line up my data, but it have to be all milligrams or grams. So these have to be the same. I'm going to convert the grams into milligrams by multiplying by 1,000. So that gives me 9,000 milligrams. So now I got milligrams and milligrams. I can solve this problem. Okay, I see that they match, so I can go. Now you could have also done figured out everything in grams, which would have given you 0.012 grams over 900 grams. Okay, either way you have your assumption. Make sure that you're lining up your big amount, the million with the question mark, and then your small amount over your big amount. Whatever is crisscrossed, you multiply, you divide by what's left. So this would be 12 times a million divided by 900,000, which gives you 13.3 ppm. Over here, same deal, whatever is crossed you multiply, and then you divide by the leftover. It doesn't matter what side this is on, it will give you the same result. 0.012 times a million divided by 900 equals 13.3 ppm. And if you wanted to use the trick, you needed to convert 900 grams into kilograms, so you would have to divide by 1,000, which would be 12 milligrams over 0.9 kilograms, which would also give you 13.3 ppm. Now you have to calculate concentrations in grams per 100 mil, and you have 67 grams, and you have 325 mils, and so in this case you already have everything in the right unit of measurement, because grams and grams are there, liters and milliliters are there. So whatever you see that is crossed, this one has no value, you can't crisscross that one. You multiply and then you divide by the leftover. 67 times 100 divided by 325 gives you 20.6, and that's the value that will go there. So yes, you do need to add 20.6 grams per 100 mils. Over here you have a triangle question. So because your equation is P times T, you have to put the P and the T side by side. Okay, if you had a question of one over the top, the one on top would need to go here. This one is the energy has to go in the space that's left. And then you circle the first data, joules. Joules, you see it here, it's energy, so this is E. And then 15 seconds, you circle it, that's the time T. So you have E and T, you are looking for P. P equals, well, I'm not sure, so I hide it. Oh, it looks like it's E divided by T, 20,000 divided by 15 seconds. If we put joules here, and this gives me 1,333.3, and these are watts because I see it here, so I add the watts. Okay, here you just need to know that this symbol is infectious substance. Here it says in the graph, explain the effect of time over temperature. Well, this is time, and I've told you that you're always looking at what happens to y when x increases. So as time goes by, you can see that, you know, what happens to y here, which is the temperature. So you can write as time goes by, the temperature and then so here you can see that since the curve is going up like this, it's increasing, and the tangent here is really steep, so it increases really quickly first, then it reduces, so it goes slower. Okay, so the temperature increases rapidly, then slowly. What was the temperature after 30 seconds? So you have to look at your graph. This is the temperature, the time 30 seconds. So after 30 seconds, you're looking at 1.5 degrees Celsius. Okay. According to you, what is the experiment? Well, they're saying heating water, but we're in the negative, so we're probably melting ice here. Heating up and melting ice. Okay, what do you think the person did to make the temperature decrease at a slower rate? So it went really high and then it started decreasing. I would probably say that they reduced the heat. So essentially, I just want you to be able to look at data and imagine what's going on. Okay. Here it's asking what is the difference between W and Z. Well, W is here and Z is here, so it's this line and this line. Essentially, W had a low population numbers before the burn. Okay, so this is population number. This is the year of the fire, which is the burn, and then what happens over time. Then increases. So the burnt environment was a good environment for W to grow, so it went up. Okay, again, Z here had a high population. Numbers before the burn, then decreased and never really successfully repopulated after the burn, so it does not live well in conditions after the burn. And this one we're just going to cross it out because we don't have time. Okay, malaria information. Malaria, a serious disease, is caused by a parasite that is spread by the bite of an infected mosquito. So the parasite infects the mosquito, who then bites a living person that then receives the malaria. So the parasite is causing malaria in the people. People traveling in areas where there's a high risk of contracting malaria used to be prescribed chloroquine pills to prevent the disease. Now, other treatments are usually prescribed because chloroquine is no longer guaranteed to be effective. What's the most probable reason for this medication to be less effective in preventing the disease? So the malaria parasite has developed a resistance to the medication. So this would mean the parasite is now strong and can survive through this substance that usually killed it. And this is the most probable reason. This is the only one that makes sense. if mosquito developed a resistance to the parasite, they would just, well, they still do survive, so this would not affect the medication's effect on the disease, okay? People have developed a resistance to the medication. Well, they already did. They didn't really have issues if they were taking the medication in the first place, so that one doesn't make sense either. And people have developed a resistance to the malaria parasite. Well, if that were the case, we wouldn't have any issues contracting it, so having the disease wouldn't bother us, so that doesn't make sense either. Last part here, relationship between road salt concentration and species population in ponds. So this is just showing that when we put salt in the road to melt the ice, it ends up in the pond, and concentration of this salt affects some organisms. According to the graph above, an increase in the concentration of road salt in ponds from 0 to 0.1 ppm results in a decrease in what number of species? Well, in this case, you really have to look into this area here, okay, and look at what line in this area is decreasing. This one's stable, this one's kind of going up, and this line is the only one decreasing. So for this question, only organism 2 decreases. And you know what, we'll skip this one for today. I think that's long enough. And good luck on your quiz.